Well, hello YouTube. In the last video, I was attempting to test a couple of capacitors using this little gizmo here, and this thing, I've had it for years. It was a kit. Can't say I really trust it. So, and it's supposed to be an ESR meter. So I went on Amazon and searched to see what was available, and I picked up a new tester. So let's slide these out of the way for now, because what I'm going to do is I have a variety of salvaged capacitors here that we are going to test, see what values we get. We're going to record them and compare it to the new tester. This is what we have. It is a Neotech transistor tesmatic checker detector. It was sold as a transistor tester. I believe it was $25. There are numerous versions of these. Some are kit, some are in plastic plexiglass cases, some are not in cases at all. Some have rechargeable lithium-ion batteries, some are powered by 9-volt. I picked this one because it was a pre-manufactured unit. It ran off of a 9-volt battery, and it was sold as a transistor tester, but it supposedly can check. It's a component tester, basically. It is supposed to automatically identify what the component is and what the values of it are, which is why these are over here too. All these parts were salvaged from the same circuit board. So I already did open this to check to make sure everything was there. We have our 3 test leads. We have a powerful cell, extra heavy battery. Well, it doesn't feel like it's extra heavy, but we'll take their word for it. Have some instructions. And we have the tester itself. Peel the cover off the screen. It appears to be a approval stamp or something on there. And inside the battery compartment, we have, basically it's a ZIF socket, and you can either plug whatever you're testing directly into here, or you can plug the leads directly into there, which don't seem very secure. Or you can plug the ZIF socket in and clamp whatever part you're testing into there. Now that feels a little bit more secure. We have 3 connectors, and they can be in multiple configurations, so we'll just go 1, 2, and 3, and we'll just do it like that for now. Let's get our battery. Alright, powerful cell. doesn't even fit. There we go. So this is obviously a universal case because there's tabs on the side to hold contacts and springs, as if for a pair of AA batteries. Sure to give you enough wire, that's for sure. Okay. So let's take a look at, so should be able to detect transistors, diodes, dual diodes, MOS, SCR, resistors, inductors, capacitors, capacitor, and capacitor ESR. Language setting. Turn it on. The logo will appear like picture 1, then press the test button long time till the language setting appear like picture 2, which we can't read at all. Next, choose the suitable language. Press the test button long time till the test page appear. Pins of the electronic components can be connected to the 1, 2, 3 pin optionally. Automatic identification type can detect the pin sequence, graphic display, and parameters automatically. If you want to test a triode, you do not need to worry about the base emitter or collector order of 1, 2, and 3 pin. You just, I don't know why it's saying triode. I believe they're meaning transistor. So, note, the test pin couldn't be stuck into the socket in same number like 1 and 1, 2 and 2, 3 and 3 like picture 3, 4, 5, or it will lead to short circuit. Please stick it in different numbers such as 1 and 2, 1 and 3, 2, okay. So it's basically telling you not to bridge the same pins. Range of transistor. Resistance testing is 0.5 ohm to 50 megohm. Inductance testing is 0.01 microhenries to 20 henries. Capacitance is 25 picofarad to 100,000 microfarad. So, capacitor discharge must be done before testing capacitance. Needs a long time to test high capacitance. It would be better to use IC locking adapter when testing transistor to avoid damaging the socket. Oh, okay. We found that out already. IC locking adapter is in the battery cover. Okay, that's the instructions. So let's turn it on. So we have a test button and we have an off button. We don't have an on button. Well, let's turn it off and see what happens. Oh, probably the test button turns it on. Yep, there we go. Too bad it's not a transformer tester. Testing. Okay, well, it's already in English. 7.3 volt battery. No, unknown, or damaged. Okay, let's just put one of these resistors across it and see what it comes up with here. It's supposed to be a 4700 ohm, 7 watt. Okay, resistor 4772 ohms. So that's pretty close between pins 1 and 2. let's just check one of these transistors here. And of course, there's a huge glare right where the screen is. That's a little better. Okay. So that appears to work. All right, now let's bring our other capacitors in here and see what we can get out of these with the tester that I had. Again, we have a range variety of capacitors, have a few electrolytics down at the bottom, a few ceramics, some metal film capacitors. This one up here, I'm not sure if that's a ceramic or a mica or what it is. I think it's a capacitor, but we're going to test that one as well. See what this guy will say. Give us results. We'll write them down and compare it to the other tester. So to start off, well, leaky. We're going to start off with this little one here. Okay. Point. We're just going to say 624 and ESR is too high. And our last one. Two, 8.1, 8.2. Okay. Now, let's just see what happens when we put this It can measure ESR. It can measure resistance. Let's put it across a resistor and see what happens if anything shows up. No, not at all. Okay, let's bring in our new tester and see how this fares. So let's just go with the black and red leads. Okay, capacitor. 4586 picofarad. V loss 0.02%. Well, it's a 4700K, so that should be good. Capacitor V loss 0.01%, and it's 18.59 nanofarads. If you guys that are good at math can figure this out on the fly, great. I'm not. Okay, 134.5 nanofarads. .32 picofarads. This is the one that was not reading anything. .1111 picofarad. 0.0012 is what this is supposed to be. I'm assuming that is measured in microfarad. So now we are into the metal film capacitors. .3858 picofarad. Well, it's showing 3900. So I'm assuming that is going to be showing the correct value. Again, not positive. Don't have anything to convert with or to at the moment. Okay, 789 picofarad. And this one's saying 820. Alright. Here is our good all. See if it's any good at all. Saying 630.39 plus minus 20%. Okay, now we're showing ESR values. So 410 nanofarad, which was showing 0.4 or 0.546 on the last one, at a 77 ohm. Definitely not the same. Let's try testing again and see what happens. 410. Not even close to what the other meter showed. So we're on these. Saying 0.1. .6 nanofarad. So that's pretty much spot on. Okay. We have another one of these, same type. .66 nanofarad. And the same. Alright, here we are at these. Should be 0.1 microfarad. Or 1. .45 nanofarad. It's close. It is. Doesn't have a percentage on it. And again, not really sure how accurate this is going to be, because it's definitely not testing it at 1600 volts DC. 93.66. Again, it's close. Alright, so we're back up to the top here. This is one of the ones that was actually showing an ESR on the other meter. It's supposed to be a 2 microfarad, 20% capacitor, 100 volt. Okay, 1745, it was showing 1.88 on the other meter. 0.1 ohm ESR. The other meter was showing it 19.2 and 28. It was jumping back and forth. Let's test it again. 1745.11, same. Okay, we'll come back to that one. 17, let's mark it. 1745. And 0.11. Okay. Now the electrolytics. So this one's supposed to be 300 microfarad. It was showing 512.4 on the other meter, which reading that much higher is just signaling that it's bad, basically. ESR goes up. Okay, 450.5, which is lower than the other meter was reading. 0.6 ohm, which is also lower. Let's try testing again, see what we get. Okay, now we're down to 0.06 ohm ESR, 453.8. Alright, the next one, which is one of our cosmic capacitors. These are supposed to be what? 150 microfarad. Showing 160.4 and a 2.3 ohm ESR. So we were reading on the other meter was 178.6 with 3.8 ESR. Okay, ESR went down, capacitance went up, I think. Our last one, which was originally, again, this is supposed to be 150, was reading 218. 196, 4.8 ohm. Again, I would not rely on this to determine whether a capacitor is good or bad. But for a quick value check on something, if you're not sure what it's supposed to be, I'd say it's probably all right. See if I have a new transistor somewhere, or capacitor. Okay, 1747.010, so we're about the same on that. So let's try to test out a few of these other components. See if they're any good. These should be a little bit more reliable, as they're not, well, they're not capacitors. So it's either it's going to be a resistance or whatever. So this is supposed to be 4700 ohm. Showing resistor 4759. Okay. Another resistor, again 4.7, well, 4.7 kilo ohm or 4700 ohm, it's the same thing. $49.39, that's reading a little bit high. 10%. $49.37, okay. It's consistent anyway. Now, one of these registers as a capacitor or something, there's a problem. $35.90, I believe this was a 3.3. Okay. Those are a few precision resistors, I believe. This is a diode, standard diode. It's a Motorola MR996A. See if it shows it as a diode. It should, unless it's bad. Diode. Okay, cool. From pin 1 to 3. And if we flip it around, You'll either reverse the symbol or reverse the numbers. Let's see what happens. Yep. Cool. That works. Okay, we've got some precision resistors. 2K, 1%. $2,019. Okay, 8.06K. %. 8267. I think that might be a bit out of tolerance. Again, I'm bad at math, so it might not be. Okay, 200K. Again, 1%. Okay, 199.8K. So that one seems good. This one I'm not sure what it is. Looks like a resistor. Dale. RN650. Actually, that might be a diode. .0. Okay. And now we have a few transistors. This is, what is this? 2N5459. So we'll use our third connector here. Okay. So that looks good. Okay. I believe that is the same transistor as the last. Yeah, 2N5459. Alright, now we've got a few more here. These are GED4, 0, and 1. Okay. NPN. This one is the same. Again, I'm not sure if I'm connecting them the same. It should not matter how they are connected. Okay. And we have a couple of these, which are GE D4, 0, and 2. Another one of those. And we have one of these old school transistors. This is a C2N3645 PNP. Okay. Alright. So it seems as though it works. Accuracy is questionable. Thanks for watching.